Alright guys, so this is the first foldable for chapter 8, I guess not a foldable, but what we'll paste into our interactive student notebook. So on this front page, your page is set up a little differently. I just put what's over here on the right. It's usually below this. I just put it over on the right to kind of fit my screen better. So the first thing we're going to do is compare and contrast congruence and similarity. Now, we've been dealing with congruence a lot, but similar is something we haven't dealt with as much, but we have dealt with it. So if you remember back to our dilation chapter, when we dilated a figure, what we came up with is a similar figure, okay? So let's look at this Venn diagram. So first of all, the symbols are different. So congruent is an equal sign with a squiggly on top. Okay, now similar is just a squiggly sign and that's it. So the symbols are very different. Okay, now congruence is when corresponding sides are congruent. Okay, and that is very different from similar because when things are similar, corresponding sides are proportional. Okay, now one thing they do have in common is that corresponding angles are congruent. Okay. All right, so if we go over here, it says two polygons are similar if and only if their vertices can be paired such that, and we're just basically going to rewrite what we wrote over here, corresponding angles are congruent and such that corresponding sides are proportionate. All right, so when we talk about the scale factor, that's how much bigger, how much smaller it's getting. And remember, scale factor is usually denoted by the lowercase k. And the scale factor is the ratio of the lengths of the two corresponding sides. All right, so now we're going to look at the next two pages, so front, back in our interactive student notebook packet, okay? And these are kind of separated, so I'll kind of pause it, but the first page has this symbol right here on it. It just says similar polygons. So I want you to take a minute and go and find this here, and it's on the back of the first page, but I'm going to give you a minute to go and find that, so go ahead and do that now. All right, so right here when we talk about similar figures, we're basically defining what they are. So it says two figures that have the same shape, but not necessarily the same size, are similar. And remember, this goes back to dilations, making something bigger or smaller. The two polygons are similar if, and we've already written this on our other thing that we pasted into our interactive student notebook, but corresponding angles are congruent and corresponding sides are proportional. Okay, and the ratio of the lengths of the corresponding sides is called the scale factor. And the scale factor is generally designated with a lower letter K. All right, so under that side we just filled out, you'll see the golden rectangle. Now, I want you to just X through this because we're not going to go over it. Our book doesn't cover it, so we're not going to cover it this year. It is very intriguing, so if you want to look into it, there's some really cool things, but we're not going to cover this. All right, so this is the next part we're going to do. Now, this is the front part of the second page, so if you want to go ahead and find this. And something that might help you is definitions. Ooh. Is on the bottom right here. Okay, so that should help you find it. So go ahead and find that now. All right, now we're just going to go over, and like I said, we did this when we did dilations. Remember when I have a similarity statement, okay? And this is what I call a similarity statement. Okay, it says something is similar to something else. Now remember, order here matters. Okay, so the measure of angle F here, if I look, F is in the second spot and B is in the second spot. So that means that angle B is congruent to angle F. Remember, angles are congruent. So if angle B is 107 degrees, that means angle F has to be 170 degrees as well. Okay, same thing over here. Now I'm looking at angle D. Well, angle D is the last one. Well, so is H, so that means that angle D is congruent to angle H because we're talking about angles and the corresponding angles are congruent. So angle H is 128 degrees, so that means angle D also has to be 128 degrees. All right, so now we're talking about side lengths because there's two letters, and we're going to set up proportions. And remember, proportions is just like a fraction. Okay, so I can say AB is to BC. Okay, so AB is to BC, so first two into second and third, as EF, which is first two, is to second, third, FG. So notice that BC is the second and third letter, and so is FG. That's why we got FG here. Okay, and then the same thing over here. AB is to DC as EF, because AB is the first two, EF is the first two, DC is the last two, HG is the last two. All right, so down here it says determine whether the triangles are similar. If so, write a similarity statement and give the scale factor. So in order to be similar, all angles have to be congruent. Okay, well, notice angle D is congruent to angle S. And I know that because there's just the 1 mark and the 1 mark. And then there's the 2 marks, so angle N is congruent to angle Y. And then there's the 3 mark, angle U is congruent to angle A. So all angles are congruent. So that's one of the 2 things that has to be true. Okay, well now we have to look at the side lengths, okay, and we have to find the scale factor. So the smallest side is 2/3. Okay, the medium size, so the middle side length here is 4, and the middle side length here is 6. And then the biggest side over here is 10, and the biggest side over here is 15. Okay, now if I reduce these all, well, 2/3 just stays as 2/3. 4/6 reduces to 2/3. 10, I didn't write 15 over here, over 15 reduces to 2/3. So because these all have the same scale factor, I can say that all sides are proportionate. And therefore, yes, triangle SUN is similar to triangle. Now remember, I have to match the order. So the S is just the single hash mark. So I'm going to put a single hash mark. Angle U is 1, 2, 3. And N is the 2. So when I go over here, I have to put it in the same order. So my single hash mark is my D. My U has the 3, so my A has the 3. And my N is the 2, so my Y has the 2. So this would be a similarity statement. Okay, now my scale factor, I've already figured that out. Here's my scale factor, here, here, and here. So I can say my scale factor, K equals 2/3. All right, now last, I know it's not on here, but our book does cover it. I'm going to write a statement of proportionality. Okay, and that's comparing the side lengths. So if I say SU is 2, so first 2 here is 2, first 2 here. SU is to DA as next to UN is to next to here, AY, as first and last is to first and last here. So this would be my statement of proportionality. And like I said, our book does cover that, and you will need to know how to write those.